Look at this map. It's not a weather forecast or a political boundary. It's a heat map of the ground itself, just south of the Norris Geyser Basin in Yellowstone National Park. The colors represent a subtle, almost imperceptible change, a phantom swelling. Beginning in the summer of 2025, a vast 19-mile-wide patch of forest, rock, and earth began to rise. Silently, invisibly. It didn't make a sound. There were no tremors you could feel, no great cracks opening in the ground. And yet, by January of 2026, a circle of land 30 kilometers across had been pushed an inch towards the sky. But what force has the power to physically lift a landscape this large? And what happens when that force decides to stop pushing and start braking? Before we answer that, I have a question for you. What is the most powerful sound you have ever heard from nature? A crack of thunder directly overhead? A rock fall in the mountains? Describe it in the comments below. Because the events we are about to witness began with a sound that would dwarf almost anything you can imagine. And one more thing, something vital. A huge number of you who watch these documentaries, people who tell us they find them valuable, forget to subscribe. For a small independent team like ours, this is a genuine emergency. It is the single factor that determines whether we can fund our next investigation. So if you believe this work matters, please take just 1 second to hit that subscribe button. It is the most important way you can support us. Do it now. It truly makes all the difference. Now, let's begin. While the ground at Norris was quietly beginning its ascent, a different kind of pressure was building just a few miles to the south, in a place called Biscuit Basin. On the morning of July 23, 2024, it was a picture of serene geothermal beauty. 209 visitors had already entered the basin that day, walking the boardwalks, mesmerized by the jewel-toned pools. One of those pools was Black Diamond Pool. For years, it was a quiet, unassuming feature. But deep beneath its placid surface, the park's plumbing was failing. Minerals, specifically silica, were crystallizing out of the superheated water, lining the underground conduits, hardening like concrete in a pipe. The vent was being sealed off from the inside. The heat from Yellowstone's magma chamber, miles below, didn't stop. The water kept boiling. The steam kept accumulating. But now it had nowhere to go. The pressure began to build, minute by minute, day by day, until the rock cap above it could no longer contain the force. And at 11:42 a.m., it failed, instantly, catastrophically. With no warning whatsoever, Black Diamond Pool detonated. A violent jet of superheated water, mud, and shattered rock exploded upwards. A geyser of pure kinetic energy. It didn't just bubble over, it cannoned into the sky. Scientists from the Yellowstone Volcano Observatory, or YVO, later calculated the debris plume reached a height of between 400 and 600 feet. That's taller than a 50-story skyscraper. For 55 terrifying seconds, the explosion raged, hurling boulders the size of car tires across a debris field that would eventually cover 1 square kilometer. The blast was so powerful it heavily damaged the nearby boardwalks, splintering the wood and reminding everyone just how close those 209 tourists had come to a lethal event. But there was a strange, almost miraculous detail that saved lives that day. The explosion was not directed straight up. For reasons geologists are still studying, the blast was angled to the northeast, firing the majority of its deadly projectiles away from the boardwalks and towards the Firehole River. A few degrees in a different direction, and the story of July 23rd would have been an international tragedy. This wasn't a volcanic eruption. Analysis of the debris proved that. No fresh rhyolite bedrock from deep underground was ejected. This was a purely hydrothermal event, a plumbing problem of epic proportions. The system simply became clogged, and the pressure cooker lid blew off. The YVO report on the incident chose its words carefully, stating that the blast emphatically demonstrates an underappreciated hazard in the Yellowstone region. An underappreciated hazard. That is the carefully chosen, scientific language for a beautiful pool of water that can, without any detectable precursor on standard instruments, turn into a shrapnel cannon in less than a minute. Think about that for a second. If you were standing there watching that pool and it suddenly exploded, what would be your first immediate gut reaction? Run? Freeze? Film? I'm genuinely curious. Let me know in the comments. The Biscuit Basin explosion was a brutal public demonstration of Yellowstone's hidden power. It was caught on camera, it made headlines, it forced the immediate closure of the basin. But what if one of these events happens with no one around to see it? Does it still tell us something? As it turns out, yes. And the story it tells is even stranger. Let's travel back a few months before the Biscuit Basin blast, to April 15th, 2024. The park is still closed for the winter season. The boardwalks are empty, covered in snow. In the Norris Geyser Basin, at a place called Porcelain Terrace, another section of ground is about to fail. We don't know the exact moment, but sometime that day, a smaller, yet still significant hydrothermal explosion took place. It blew a new crater in the ground 10 feet across, a violent pockmark on the landscape. It hurled hot water and debris, and it flash flooded the nearby New Far Lake. The water in the lake turned a milky turquoise blue from the sudden influx of silica. When the water receded, it left behind a grim calling card. The trees along the new shoreline were caked in a thin layer of silica, essentially petrified where they stood. Suffocated by liquid rock, they are now known as the silica trees of death. No human being saw this happen. No one heard the roar. There were no tourists to run for their lives. And yet, this quiet, lonely explosion made history. Because for the first time ever, a hydrothermal explosion in Yellowstone was definitively heard, not by human ears, but by technology. A newly installed network of monitoring sensors, combining traditional seismometers with sensitive acoustic monitors, recorded the event. The seismometers picked up the violent ground shaking as the rock fractured. But the acoustic sensors picked up something else: the sound. The low-frequency thunder of the explosion itself traveling through the ground and the air. It was a technological breakthrough. Proof that the YVO could now detect these events even when they happened in the most remote corners of the park. Yellowstone was being wired with an ever more sensitive nervous system. The invisible threat was becoming, for the first time, electronically visible. And the data from that invisible explosion only deepens the mystery of what's happening in Yellowstone right now. The scientists aren't just looking for clues of what to fear, but for knowledge that can keep people safe. And sharing that knowledge is just as critical. If you know anyone, a friend or a family member, who is fascinated by the power of our planet or plans to visit a place like this, do them and us a favor. Please hit the like button so this documentary reaches more people, and use the share button to send it to them directly. Spreading this awareness is a huge help, and it's a core part of our mission. These explosions, both the spectacular one at Biscuit Basin and the invisible one at Norris, are the violent symptoms of a much larger, much deeper process. They're the final, chaotic release of pressure. But to truly understand the risk, we have to look for the source of that pressure. And that brings us back to that strange 19-mile-wide bulge in the ground, the Norris Uplift Anomaly. This isn't the first time this exact patch of ground has swelled. Geologists have been watching it for decades. Between 1996 and 2004, this same area rose by nearly 5 inches. The ground itself was inhaling. Then, for the next 16 years, it slowly exhaled, sinking back down by about 2.5 inches. This cyclical movement is what scientists call breathing, and it's driven by what lies deep beneath, about 9 miles or 14 kilometers down. There is a pocket, a reservoir where either magma or more likely superheated, mineral-rich brines are accumulating. As this deep reservoir fills, it pushes the ground above it upwards. As it empties or cools, the ground subsides. So when the ground started rising again in July of 2025, it wasn't entirely a surprise. It was a known behavior. But the context was different this time. The entire Yellowstone caldera, the massive 45-mile-wide basin that makes up the heart of the park, had been steadily sinking for nearly a decade. Since 2015, the caldera floor had been subsiding at a steady rate of about an inch per year. This was seen as a sign of the system calming down, releasing pressure. But in the winter of 2025 to 2026, for the first time in 10 years, that subsidence stalled. The entire system seemed to hold its breath. And at the exact same time, the Norris area began to swell upwards. It was a profound shift in the park's dynamics. The quiet, decade-long exhale of the caldera had stopped, and a new focused inhale had begun at Norris. Then came the earthquakes. In November of 2025, just as the uplift was nearing its peak, the University of Utah seismograph stations recorded a significant earthquake swarm. Hundreds of small tremors, too small for a human to feel, began rattling directly beneath the 19-mile-wide bulge. This was the smoking gun. Earthquakes don't happen randomly. They happen when rock is put under stress and breaks. This swarm was the sound of the crust cracking and shifting as that deep pocket of fluid or magma 9 miles down continued to inflate, stretching the ground above it to its breaking point. It was the creaking and groaning of a system under immense strain. Michael Poland, the scientist in charge at the YVO and the leading expert on this activity, put it in calm scientific perspective. He noted that because there is a known active magma chamber down there, it is, in his words, not surprising that there's stuff moving around down there. He is quick to dispel doomsday scenarios, clarifying that if a true volcanic eruption were imminent, the ground deformation would be vastly larger, measured in feet, not inches, and happening much, much closer to the surface. This is not a supervolcano waking up, but it is the system's engine revving. It is a sign that the vast complex plumbing network is being energized from below. And the surface was beginning to respond in other ways too. While the ground swelled and the earth quaked, the geysers themselves started to change. In February 2026, just as the uplift mysteriously paused its upward movement, a geyser roared back to life. Located right in the heart of the Norris Geyser Basin, Echinus is the largest known acidic geyser in the world. After years of relative slumber, it suddenly reawakened, erupting roughly 40 times in a single month. This wasn't a coincidence. The changes deep underground were manipulating the plumbing on the surface, opening up old channels and redirecting the flow of superheated water. The reawakening of Echinus was another piece of the puzzle, another surface-level expression of the deep unrest. It's like shaking a complex network of pipes. You can't be sure which faucet will turn on, but you know the water is moving. It's an intricate dance of cause and effect. The deep fluid injection causes the ground to swell. The swelling stresses the crust, causing earthquake swarms. And the shifting, cracking ground reroutes the hydrothermal fluids, causing dormant geysers to dramatically spring back to life. All of these recent events, the Norris Uplift, the earthquake swarm, the reawakening of Echinus, even the violent explosion at Biscuit Basin, are not separate, isolated incidents. They are chapters in the same story. A story of a system being repressurized. Okay, I have to do this. I'm looking at our channel analytics as I'm recording this, and a truly mind-boggling number of you watching right now still haven't subscribed. Seriously, what am I doing wrong? Don't make me use the stern park ranger voice. Sir, ma'am, please keep your hands inside the vehicle and click the subscribe button. But in all seriousness, hitting that button is the single most effective way to ensure we can launch our next deep dive. It takes one click. It costs you nothing. And it means everything to us. I'll wait. Okay. Thank you. Sincerely. Now back to the massive geological engine stirring from its slumber. While some features were waking up, others were curiously going to sleep. Steamboat Geyser, the world's tallest, which also lives in the hyperactive Norris Basin, seemed to be doing the opposite of Echinus. After a period of record-breaking activity that peaked with 48 eruptions in 2020, its frequency was dropping off a cliff. It erupted only 6 times in all of 2024. This isn't a contradiction. It's a confirmation of the chaos. It shows that the underground plumbing is being dynamically rearranged in real time. What opens one channel may pinch another. The system isn't just turning up the volume everywhere. It's rerouting the entire symphony. The energy is shifting, creating new hazards in some places and quieting old ones in others. This makes the entire basin maddeningly unpredictable. You can't just watch one geyser, you have to watch the entire system. And even in places that have already exploded, the danger doesn't just vanish. The site of the massive 2024 Biscuit Basin explosion is still very much alive. After the initial blast, the YVO, in partnership with the University of Utah, wired the new crater with a dense network of sensors. Seismic, acoustic, and temperature probes plunged directly into the turbulent water. The wound was now being monitored. And in late April of 2026, the sensors twitched. On April 28th and 29th, the crater erupted again. These were smaller events, not nearly on the scale of the 2024 blast. But the eruption on April 29th was the largest detected since the monitoring equipment was installed. The beast was stirring. The plumbing, it seems, is trying to clog itself again. The fact that the system is capable of repeated explosions from the exact same vent, just 2 years apart, is a sobering confirmation of what the scientists have been saying. These aren't thousand-year events. The potential for these steam-driven blasts is an ever-present part of the park's reality. It is crucial to understand that despite all of this, the swelling ground, the earthquake swarms, the historic explosions, The official alert level for Yellowstone remains at normal. The aviation color code is green. Why? Because all of this, is normal for Yellowstone. It's what a living, breathing, active caldera system does. The public imagination is captured by the idea of a single, world-ending super-eruption. But the geologists who spend their lives studying this place are focused on a different reality. The reality is that Yellowstone is a place of constant, smaller-scale violence. The hazard isn't a single event in the distant future. The hazard is now. It's the ground you walk on. It's the water you admire. The misconception is that these explosions are triggered by new magma suddenly hitting groundwater. The evidence from the 2024 blasts proves this is wrong. It's a plumbing issue, not a magma issue. The heat source is ancient and constant. It's the network of pipes and vents that is fragile, temporary, and constantly changing. The very minerals that make the hot springs so beautiful, the silica that forms the delicate crusts, are the same materials that can turn a peaceful pool into a time bomb. It's a paradox written into the very geology of the place. The beauty and the danger are made of the exact same thing. And the scale of this danger, seen over geologic time, is staggering. We look at the 600-foot plume from Biscuit Basin, and we are stunned. But Yellowstone has a history of creating hydrothermal explosion craters that make Black Diamond Pool look like a firecracker. Craters like Mary Bay, over 1.5 miles wide, the result of a steam explosion with the energy of a nuclear weapon that shattered the Earth 13,800 years ago. These events are rare, happening on a time scale of thousands or tens of thousands of years. But smaller ones, those that create craters hundreds of feet across, happen every few hundred years. We saw Pork Chop Geyser explode in 1989. We saw Black Diamond Pool explode in 2024. The system is still active. The engine is still running. So, where does this leave us? The 19-mile-wide uplift at Norris has paused for now, but the ground has been changed. The system has been repressurized. A decade of quiet subsidence has ended, replaced by a new phase of focused swelling and seismic release. Explosions that were once theoretical hazards for tourists are now documented, measured, near-miss events. We have learned that these blasts can happen with zero warning from our traditional monitoring networks. We have learned that only by blanketing these areas with advanced acoustic sensors can we even begin to get a sense of the invisible events happening away from the boardwalks. We have learned that a change in pressure 9 miles deep can have dramatic and unpredictable consequences on the surface, waking some geysers and silencing others. We are watching a geological story unfold in real time. We don't know what the next chapter holds. Will the Norris Uplift resume? Will the earthquake swarms intensify? Will another clogged conduit in another beautiful basin fail catastrophically? The scientists at the YVO are watching. Their network of GPS stations, seismometers, gas sniffers, and now acoustic sensors provides the most advanced volcanic monitoring on Earth. They are not looking for doomsday. They are charting the vital signs of a living planet. And I am dedicated to reminding you one final time that subscribing to this channel supports our ability to bring you these vital stories. Okay, I'm really done now. I promise. But seriously, to every single person who has clicked that button, thank you. You are the reason we get to do this. All of this science, all this data, it leads back to a simple, profound truth. Yellowstone is not a museum. It's not a static landscape painting. It is an active, dynamic, and fundamentally unstable place. The breathtaking beauty that draws millions of people from around the world is the direct surface expression of a violent, high-pressure engine that is constantly churning just out of sight. The rules, the boardwalks, the warning signs, they are not suggestions. They are the fragile membrane between us and a world where the ground can swell, crack, and explode. We come to Yellowstone to feel a sense of awe, a connection to something primal and powerful. But the events of the last few years require us to add another layer to that awe, a deep, fundamental respect. The image of a family smiling on a boardwalk is an image of trust. Trust in the ground beneath their feet. Trust in the predictability of the world. But the lesson of the Norris Uplift and the Biscuit Basin explosion is that in Yellowstone, that trust must be earned, and it can be broken in an instant. The real threat isn't a Hollywood fantasy. It's the quiet, beautiful, steaming reality. Right there, just on the other side of the railing. And it's more active now than it has been in a decade.